Hi everybody, I am Magnus Glans. I work as a solution architect at Red Hat and I am going to show you how to create patch management as a service using some cool tools, using an automation framework called Ansible and using a management product that you can do Ansible with called Ansible Tower. And Ansible Tower is something that my company Red Hat sells support for. And it's built on an open source project called AWX. Okay, so this is not at all prepared. I'm just improvising a lot, so have some patience with that. But with that said, let's begin. So I just logged into Ansible Tower here and you can see some stuff going on here. It's quite a simple tool itself. You're watching an overview where we can see that Ansible playbooks have successfully executed a number of times, and sometimes they also failed. So I'm guessing that you are comfortable with the concept of Ansible, and you might be using it even. So I mean, it's a simple automation framework. It's clientless and was created to solve a lot of the problems or challenges that we had in other automation frameworks like Puppet and Chef, for example. So you can build your own opinion about Ansible, or if it's something that you think is cool. But what I'll be doing here is really cool and simple. So first off, Ansible Tower has a concept called a project, and that is where we can import something called a playbook, pieces of automation for Ansible automation, basically. So regarding patch management, so typically I see at companies there are different departments. There's a department which maintains operating systems. There are departments that maintains application servers or applications on top of these application servers, and databases and pieces of network equipment and so on. And we can all argue if this is sane to organize a company in that way, but fact is that a lot of companies looks like that. Will perhaps change going forward, but that is a limitation that a lot of people have, that you cannot write automation to automate anything because someone else has kind of monopoly to automate a piece of network equipment, for example, because of separation of duty and just because it's always been like that. Yeah. So anyways, so I'm thinking that there will be a department that manages operating systems. So they will have their own project which contains the automation for operating systems. So we'll call this operating system department, automation for OS. Okay, that's all right. And then we will select an SCM type. You can see there are support for most variations here, and we can select manual as well, which just uses a local file system on the Ansible Tower server. Anyways, this is so we can store our automation in form of in a version handling system, which kind of makes sense, right? So I have here on GitHub, here's my GitHub account, so all the stuff I'm doing is available on GitHub. I created a repository called A Playbooks Patch OS. So this is the where I'll keep the playbook for patching an operating system. So if I have credentials to log in here, I can select that. If I want to use different branches, I can do that. So I could have a project here which points at the dev branch or test branch or master production branch for patching operating systems, for example. Anyways, I'll just save. That's simple enough. And I'll see Ansible Tower go to work, and it's pulling down the whatever is in this repository. So that will be my playbook right here, the patch OS automation that I'm going to use. So that seems to have worked out nicely. So now that that has been done, I'm going to create a piece of credentials. So an issue with automation, or when you're going to do patch management or whatever, automate whatever process, is that in order to do something, and most typically to be able to patch something, you will need administrator access to that system. Now that is a piece of access which you will not typically want to give away because of security concerns, or because it is a really powerful piece of credentials, and with it you can do anything. So as now I'm pretending that I'm responsible for operating systems at the company, and my concern is that there's some guy that's asking me to be able to patch their systems by themselves because they are part of a up-and-coming DevOps team. Now, I'm concerned that they don't really have the education it requires to really know what they're doing. So if I give them admin access to my systems, this means that they might be able to figure out how to patch in a safe manner, but yeah, they could also destroy a lot of things. But I would really like to give them the ability to patch their system by themselves, because this will offload me. Ansible Tower has a neat feature here which allows you to share access, to share credentials without actually sharing what kind of user or password is used to gain access to the system. This is cool. So we'll create a piece of credentials here, and I'll just call it required access to do OS patching, or to run OS required access for operating system, we'll call that. Okay, the description will make that the same. Cool. What kind of credential type is this? Well, I am at a company where we don't really have a lot of advanced access here, so I'll, instead of using a service account or a SSH key or something, I'll just select a username and password, and in this case it will be the root user. So just what kind of user we are using here would be considered maybe a security risk to share. As you can see, when I save these credentials, typed in the root password, it now says encrypted. So, and this means that it's a one-way street. This, you put something in, you save it, and you can never get it out again. And this is neat because it means that I can share credentials even though I am the only one that knows the actual password here. And the guys who I share the credentials with, they'll never find out what the password is. Cool. Okay, so I'll be using that credentials soon. And next is to create a template. Now a job template, that is basically just a concept for running a playbook. So I'll call this playbook. I'll call that demo patch OS. All right. Secondly, I'm going to select what kind of systems is this playbook, this piece of automation that patches an operating system. What are you allowed to run that on? And so I'll select something here. So I already prepared some groups of servers that I can run automation on. So I'll select dev servers in this case. So good. Project, if you remember what a project was. So that is a place where we keep automation. So I'll just select that and choose the patch OS automation piece. This is what actually does the patching. Then I have to select what kind of credentials should be used here. And I select the credentials I typed in earlier here, called required access for operating system. Good. That is all I need to do at this point. So I'll just press save. Now, in reality, should this have been a more advanced piece of automation, maybe I would add some options for prompting the user for some arbitrary information, perhaps. But yeah, this is a real simple demo, so I won't do that. So we can then just filter on demo. I can see here's my piece of automation, and if I just click here on this rocket, I'll launch the automation as well, and I can now see that the patch OS playbook is running against the dev servers, a collection of servers that I call dev servers. Good. So I should see on my right hand side here when the automation starts to execute. So does that, and I can see that it runs against two servers, one called dev app server and one dev db server. Okay, that seems to have worked out nicely. So it says a patched Red Hat Enterprise Linux, and it says that it's currently now, after patching, running on RHEL 7.4. Okay, that was just some additional info for me there as a user. Cool. So on our left hand side here, we can see a bunch of automation information here. We can see when did the automation start to execute, when did it complete. We can see that it was run successfully, obviously. We can see what automation was run, launched by what user, and against which servers, which revision from Git was used here actually, and what piece of credentials were used as well. So that is kind of neat, right? But as you can see, I'm still logged in as the admin user, and that is not really sufficient, I think. So we will, oh, I misclicked. This is how it is when you're doing something live. I'll select the users in the tower settings here. And I'll create a user which I'll call Mr. Patch. Mr. Patch at localhost.local domain, call that patch user, and I'll create some username and password for that user. Now this is just wouldn't be like this in an enterprise environment. You would connect Ansible Tower here to your Active Directory or LDAP system or something like this instead. Anyways, this is just for me to show this. So I created a normal user, select some different types of users as well, and but I'll go straight to the permission tab here, because I want to add the permissions to this patch user to allow that user to execute the automation that I just created. You remember the demo patch OS thing here. And I select a role as well, and that will be an execute role, not an admin role, meaning that this user cannot change the automation, can barely run it. Okay, and that is it. I'll just give him access to actually to see the dev servers, but yeah, I'm not going to do that in this case. Yeah, I want to keep it as secure as possible. So I created a user, I log in as patch user, there we go, and this looks a bit different, right? I can see that this piece of automation has been run once. If I go to templates where I can see all automation visible to me, I can only see the patch OS thing here. And as this user, I can click on it, and the patch OS automation will be running against a set of servers which has been predefined by the administrator. So the only thing I can do is run this piece of automation at my leisure. And it wouldn't necessarily have to be via web GUI, could be via REST, for example. So with fairly little effort, I created a patch operating system as a service thing here. But we won't stop there, really. I'll show you some more things here as well. You can see that regarding credentials here, if I click on try to access what kind of credentials are actually used here in the system, I can't really see that. If I go into the piece of automation here, see what kind of information I get. No. The only info I get regarding what credentials access is actually used here is the description I defined earlier, required access for operating system. So the administrator of the system doesn't even share that what kind of user is used here. And that might be something desirable for some people. If I go into inventory here, it's just blank. Go into projects, try to see what kind of automation is, where automation is pulled from. There's no information either. It's just one thing, and that is the ability to run this patch OS playbook. And further on, I can just click on this as well, schedule future job template runs. And this will allow me to schedule a run at some future time. So I'll call this patch window 1. There is a start date here, that is the date of today. And maybe this is something I want to repeat every month, for example. And it should be on a specific day, for example, the first day of the month, for example, could execute. Or we can select on the first we can select on the first Sunday of the month, or on the first Monday of the month, etc. etc. But in this scenario here, we'll select on the first of the month. We'll do patching, and we can select at what time should it happen as well. So we'll select 4 in the morning. Cool. And then I can just select save. Now we've created a patch window for our servers as a normal user. This is quite cool. I can by myself control when my servers should be patched. I don't have to ask someone for it. I just go in here where I've been granted access and add a schedule. And if I want to skip a patch window, well, I can just disable the patch window here by simple click of a button, or I can enable it again. Cool. All right, but patching an operating system, just that is not as simple as it looks in reality, right? It's not just doing yum update on a system and possibly rebooting it. There is something more that we have to do, and this is actually the reason why I opted for Ansible. To patch a system is much more. It is about I mean, most systems are multi-tiered. They consist of several pieces, meaning that the first step is likely to, or likely, it might be that you'll go into a load balancer perhaps, and you'll tell the load balancer to please switch to the other side of the system in the other data center or something, and then you'll take down and maintain and patch the A side of the cluster while the B side is still running, for example. And yeah, so this is typically referred to as blue-green deployments. So that is what I will be showing you now. So let's log out our patch user and go back as the administrator. So let's imagine that we did have a system, and it consists of multiple pieces. So likely the operating system department don't want to share a Git repository with the other teams. So I'll create here an application X department, and select Git, and I know that I have here a repository which contains a playbook which to patch an application. Good, so I'll just save that. And I should see Ansible Tower automatically pulling the content of this Git repository. Yeah, good. I can see that there is a revision there. And what more? Yeah, for example, there will be a load balancer involved here as well. So let's create another project which contains the automation for the load balancing department. Load balancer department. There we go. They also keep their automation on Git. Yeah, I'll save that. So, and so by keeping things in separate Git repositories, it's just reflecting this this imaginary company of mine where these departments aren't really working together. They don't have, I mean, it's not just full DevOps, and even if it were, there might be reasons to keep things in separate repositories, because there would be separate people, for example, authorizing pull requests and stuff like that. Yeah, okay, so we have pulled in the automation for patching an application and doing stuff with a load balancer as well. So these various departments, for example, the guys who manage the application, for example, they would create a job template, patch, which they would call something, in this case, demo patch appx. And they would define which servers this piece of automation can run against. And we'll select place where to fetch our app. This is the piece of automation will be running, and as well they would define a piece of credentials as well needed. So I won't recreate a specific credential here, I just reuse the one I have. Just save that. That is done. And we'll create a piece of automation as well for doing the load balancing stuff. Demo load balancer set green, we'll call that. So going into a load balancer and switching to the green side of the cluster. You can see there's a job type here that I accidentally clicked on, so I'll explain what it is. You have the ability to run a piece of automation, either run or check, where check is just don't actually run it, just see if it would be possible to run it. I'll select some servers here to run the load balancing stuff against, and in this case here, actually the load balancers, they are not these dev servers, so it's load balancers are put into another inventory, which is called prod servers. I'll select the project, the load balancer project, and I'll select a piece of automation. This is set green, it's called, and select a piece of credentials. So these would be credentials to access the load balancer, of course, but simplicity, I'm reusing stuff again. Okay, now that's done. So if I just filter on demo, here I should see 3 job templates: patch operating system, patch app, and this here, which is a load balancer set green. Okay. So, but now it would kind of be a bit of a bummer. So if I would now go into my users here, and I could grant this patch user access to each and every one of these templates to be able to run them. But then the user would have to figure out in what order to run them. First, configure the load balancer, and he'll click here. Then, what should he patch the operating system maybe, and then go ahead and patch the application. As you all know, when you have people try to do things in the correct order, at some point it will go bad. So let's try and make it a bit simpler for our patch user to execute things in the correct order. So we'll create another template here, a special one, which is called a workflow template, and we'll call that patch your systems. There we go. Just save that. Now we can add service here to query the user for information as well. We'll go straight into something called the workflow editor. So this is a way for us to stitch pieces of automation together. So first, what was it? So we'll filter on demo here. See the playbooks that I created. The first thing to do would be that the user would configure the load balancer. Now, afterwards, he would patch the operating system if patching the load balancer was successful. So we'll select that. And then what? Well, then you should patch the application if patching the operating system again has been successful. We'll select that. So now we have a chain here. And as you could see, we could possibly have multiple options here. In case of failure, we could do something different and so on. But we don't have to do that. I just have to show you the principle of it all. Cool. So I just save this piece of automation, which I call patch your systems. And I'll go to my users, access my patch user. I could actually access this. I could do this via the template itself as well, to from there add permissions to this user, but I'm doing it from this point now. So I'll select from workflow templates, patch your systems. I'll select that. Select a role for the user, which is just to be able to execute the piece of automation and nothing else. Cool. And that is all I need here. Actually, I removed the access to the just patching the OS. That is not needed. I log out, log back in as our patch user, and now you'll have to imagine that as a user, I've now been told that please go into access this system, Ansible Tower, and if I want to patch my system, I click on the rocket, and then my systems will immediately get patched in a safe manner. And if I want to schedule patching in accordance to my service window, I go ahead and do that. And if I just click here on the rocket, you'll see what happens. And then the view is a bit different. Here I can see that the first part of the process is running, which is setting the load balancer to so that traffic doesn't actually enter these systems, and it will light up as green once this has been completed. And if I'm wondering about what the status of things are, I could typically click there, but I haven't been actually I haven't been granted access even to see this, to see the details of what's been done in each piece of automation, because the administrator basically doesn't trust me to do anything or see anything. He has to click a button to patch my systems. Okay, that's all right. So the load balancer has been set, so no customers are hitting this specific system. That means that we can go ahead and patch the operating system, and that was successful as well. It's lit up as green, and it goes further and starts to patch my application. And yeah, so maybe after this has been done, there would be an extra step where we would do like a load balancer set to blue again, so traffic would enter the system after patching. But for all intents and purposes, that is not required in this demo, really. Okay, good. Patch my system as an end user. I'm really happy because someone gave me power to do things by myself. I created patching as a service, and I'll go into the to add this to do the patching automatically. We'll call it service window for app X, and it will be run every week on Saturdays, 3 o'clock, and it will never end. It will just continue and do this all the time. And so there is an ability here to add, for example, to add notifications. So in case that something fails, I could automatically notify the user, or maybe the people that's responsible for writing this automation would be automatically notified. But as I'm conscious that I don't want to make this demo 20 minutes long, maybe it is still, I am skipping that. Okay, so I've added a patch service window for my app when it's gonna get patched. I'm the master of my small world here, and as an end user I'm really happy because I have patching as a service. So this would typically, in a lot of companies that I meet with, this is done using very many systems, and people put a tremendous amounts of time to get what I just showed you here. And what I want you to reflect upon here is that how easy it was done, obviously, but also that this system where you can stitch automation together really allows a company, even a company which is segmented, where there is one department managing load balancers, one department managing applications, and one OS. As the end user, don't have to be concerned with that. Each department can work on their own automation, then you stitch it all together and present it as a single service to the end user. I think that is really cool. All right, that was it for today, and so it's Friday evening in Sweden right now, as you can see on my screen. So have a nice weekend, and see you later, I guess.